I can now start to calculate my quantities from all the tins that I've got created, from my road design to the subgrade, from a combination of my subgrade and design to the stripping depth, and I can just go through those different options now. Moving into having a look at the volumes for our new subgrade that we've just created, we don't really want to look at any volumes or calculations of earthwork volumes outside the extent of the design. So a good rule to get into is actually come up to the tins and create a boundary around that tin itself, around the road design. That will set the size essentially of where we can calculate our volumes. So that's the model of the tin. I'm now to create a boundary for it. I'm going to pretty standard is tin road design and just put the word BDY at the back for the boundary there. It's going to create a superstring and have some levels or three-dimensional around the outside. I can create that and then turn on that model. So that's the extents of the earthworks, and we can use that then. If I come up under the design volumes and use the exact method, tin to tin, we've got a whole bunch of tools that we can go here. So I could actually find the volume between the original, which is the existing surface, and my new tin, which is the road design. But I could limit that essentially to being just inside that polygon, so that 12D wouldn't calculate any volumes across the corners or do anything strange like that, and that could be one volume there. You might also decide to actually do it from the subgrade, which would be slightly different. Again, quickly you can just duplicate the panel if that's easier. That way all the answers that you had before would be remembered, and I could just actually change it from the original being tin not being the existing surface but that stripped depth, and if I go volume there, you can see the volume's now increased. Or again, if you wish to, you could then duplicate the panel and find out what the volume would be between the road design and our subgrade model, and find the volume within that polygon. So we've got a bunch of different volumes we've now calculated for the different surfaces. If you wish to quickly make a triangulation which was the combination of the design and the subgrade tin, we could make it a super tin for that, which would be a combination of the two. To do that, you just come up under tins, create, and it's known as a super tin. It's basically a composite of the two tins, and just the order in terms of which of the tins we put on top of each other is the way that the triangulation is created. So I'm going to put in here, going to create this subgrade super tin. So I'll just call this earthworks and hit enter there, and I'll make this triangulation purple. So we'll see that when I turn it on in the view. Now we just need to put the tins in the order from the least important to the more important on top, so or the order in which they were created. So in case I want it to come up as the part of the design, I don't want it to continue across as the design, but underneath that I actually want it to then, if it finds the subgrade triangulation, I want that to take control. So I'm going to put the subgrade in as the second step, and if I create that, the tin's now been created, and if I plus that onto the view, into the section view there, the earthworks tin, you can see that's exactly what's happening. The tin comes up and follows the design, but as soon as it finds the subgrade, it replaces the road design. So it actually steps down vertically, comes across, and then steps back up and follows the rest of the design to the end there. So that's another volume we could now calculate straight from this earthworks triangulation down to the stripping depth. So I'm just going to duplicate the panel, turn the original one as being the stripped, and the final one as being my earthworks. And if I find the volume, that's the earthworks that we now have between the two surfaces, and the pavement would be then added on top. Thank you.